In today's day and age, our world has been plunged into an energy crisis. As energy becomes more valuable, many have attempted to fix this issue, yet it still is a prominent issue around the world.
The most prominent of these attempts is the lithium-ion battery, or LIB, which include both lithium and cobalt, resulting in these batteries becoming expensive, dangerous, and damaging to the environment, as lithium is not only difficult to dispose of properly, but is also highly reactive with water. Additionally, these resources are linked to child labor from lithium and cobalt mines, and we are projected to run out of cobalt in the next 50 years.
But what if we told you the solution to this was nothing more than a box of sand? Our solution to this problem is a thermoelectric generator using hot sand, as sand's low heat transfer ratio and abundance allows for it to cheaply and easily store thermal energy. Once hot, we use thermocouples that use the Seebeck effect to convert this heat into electricity.
We were able to heat up the sand using a mirror system, where a mirror is aimed at the sand to focus the sun with the solar panel on top. This solar panel detects the sun, activating a gear system, which then pulls the mirror back, adjusting it to always have a better angle of reflection on the sand.
Math for this project was done using the heat equation. This is the heat equation. It governs all of thermodynamics. Every single law can be drawn back to this one formula. However, given that we want to solve for u, we need to do a lot of rearranging to solve for it. However, as we can see from the final results, unless we set q to be equal to 0, which means there's no internal factors, it is impossible to solve within a reasonable time period.
Additionally, we were able to use something called the California cooling system, which is where you dig a hole and whatever you put on top is cooled down. We did this to increase the temperature difference from the hot sand inside and the cool air outside, as the Seebeck effect relies on temperature difference.
Using the power of hot sand and the cool earth, our 7th and most recent prototype naturally generated enough electricity to power 11 iPhones, maxing out at 57.8 watts of electricity.
In the end, this project proved to be a safe and effective alternative to lithium-ion batteries.